Okay, guys, so next unit is Pythagorean theorem, and the whole unit is over Pythagorean theorem. So we need to make sure we understand the basic concepts of Pythagorean theorem. Pythagorean theorem deals with right triangles, like this one you see right here. It's a right triangle because one of the angles in the triangle is a right angle, therefore making it a right triangle. If you have a right triangle, you can use Pythagorean's theorem to find one of the missing sides if you have the other two. Let me say that one more time again. If you have two of the sides in a right triangle, you can find the third using Pythagorean's theorem. So just a couple things first. The two sides, the two line segments that make up the 90-degree angle, these are called legs. It's either A or B. And for the record, they are interchangeable. So it can be AB or it could be BA, either way. In other words, the A could be here or here, the B could be either one of those. What cannot and what is not interchangeable is the longest side. You know it's the longest side because it's opposite the biggest angle, which is the 90-degree angle. So always the side that's opposite the 90-degree angle, this thing is called the hypotenuse. Okay, and knowing that it is the longest side will help you eliminate answer choices. So remember that the longest side, the side opposite the 90-degree angle, that's the hypotenuse, that's C. All right, so you can look at the theorem over here and see where everything's coming from. Here I have a leg, it's A, so there's my A. Here I have a leg that's B. So these two that are on the left side of the equal sign, these are both the legs, A and B. And again, they could be interchangeable. This one could have been A, and I could be putting that number there. But what is not interchangeable is C. C will always be out here to the right by itself. It's the longest side. So that's the basics of Pythagorean theorem. You got two legs that make the 90-degree angle, long sides the hypotenuse. The A and B are the legs in the theorem, and C is the hypotenuse. Okay, so how does Pythagorean theorems work? How does Pythagorean theorem work? Okay, so the question was, if given a right triangle, and you had two of the sides, could you find the third? So let's say I said this side was 6, this side was 8 feet, inches, whatever long, could we find the third side? Using Pythagorean's theorem, you can. I'm going to start with the model, which is how they came up with the theorem in the first place. And what they found out was if you took this side right here, this line segment, and used it to make a square. In other words, something like that. If it's a square, all the sides are the same, so it's 6 by 6. Okay, and then you took this line segment here and turned it into a square. Again, square, all the sides are the same, so if this is 8, this is 8. So you have an 8 by 8 square and a 6 by 6 square. What they found was if you took the area of these two squares, the two smaller squares, so the area here would be 36, the area here would be 64, because 6 times 6 is 36, 8 times 8 is 64. They found that if you took the area of the two smaller squares, it will equal the area of the biggest square. In other words, the square coming off of the hypotenuse. So, again, adding these two, area here is 36, area here is 64, 36 plus 64 gives you an area of 100. So just look at that. Area of this the area of the two squares coming off the line segments that make the 90-degree angle. In other words, the two smaller line segments. If you square those or turn those into squares and add the areas of those, it will equal the area of the biggest square. Okay? So you say, well, how does that help me out? I'm trying to find x. I didn't want the area of the square. Well, how? If I give you a square that has an area of 100, how do you find the side of that square? You square root it. You square root the area. Square root of 100 is 10. Okay, so it's a 10 by 10 square. So same thing happens right here. If I have the area of a square, I can find the side by square rooting it. Square root of 100 is 10, which means this side is 10 just like this one is. I want to know this one because I want to know how long that side of the triangle is. And that's how Pythagorean's theorem works. If for some reason they wanted a leg, you would work backwards, doing the opposite of what we just did. So if they gave you, say this side was 10, you turned it into a square, find the area of 100. They give you this side is 6, you turn it into a square, it gives you the area of 36. If the area of these two equals that one, if you add the area of the two smaller squares to equal the area of the bigger square, then you're going to subtract these two to get this one. So 36 minus 100 is 64. So if I wanted to find the side of that triangle, what would I do? I would square root 64, and that's 8. And that's how Pythagorean theorem works. So algebraically, I'll use the exact same triangle. algebraically, you would use a squared plus b squared equals c squared. Remember, our problem is 6 by 8 triangle, right triangle, and we're trying to find x. So what do we have here? Do we have legs or hypotenuse? These are both the legs. This is A and B, or B and A. I'm going to call this A and I'm going to call this B. So in the place of A, I'm putting 6, got to square it. In the place of B, I'm putting 8, got to square it. And then C squared is what we're looking for. X is C. So from this point, you just follow your order of operations. What's 6 squared? 6 squared is 36. What's 8 squared? 64. All right. What did we do when we did the model? We turned this one into a square. That was 36, because 6 times 6 is 36. There it is. What did we do right here? We said 8 times 8. 8 times 8 was what? 64. So we could find the area of the square. There it is. Okay, and then what did we do? We added these two together so we could find the area of this square. Well, 36 plus 64 is 100. Bring my c squared down. So we found the area of the big square is 100. There it is. All right. And so what did we do to find the x? We square rooted 100 in the model, found out it was 10. Well, algebraically, how do you cancel out a square? You square root it. Whatever you do to one side of an equation, you got to do to the other. So the square and the square root cancel, or another way of saying it is the square root of c squared is c. That's what we want. And the square root of 100 is 10. So here's the algebra, and here's the model. Take a look at that for a sec. So again, here's A. Here's my A. Here's B. Here's my B. We were looking for C for X. I plug in, or after I plug in the A and the B, I square them. That's finding the area of the two squares right here. Then I add them to get the area of the big square. That's it right there. Then I square root it to find the side of this square here, which is 10. And that's how Pythagorean theorem works. Now, if I was finding the leg instead of the hypotenuse, I'm going to stay with the same triangle because we're familiar with it. So I'll say 6, but now x is going to be one of the legs. And I'm going to give you the hypotenuse. So once again, theorem is a squared plus b squared equals c squared. Okay? What do we have? We have a, so I'm going to plug in my a. We're looking for b, so that's going to stay as my unknown, my variable. And we have c now. Okay? So follow your order operation. 6 squared is 36. Bring my b squared down, just like we brought my c squared down in the last problem. And 10 squared is 100. So again, here's my a. I square it to find an area of 36. We're looking for x. You have the area of the big square as 100 because c was 10. 10 squared is 100. So there's your 100. Here's your 36. It's the area of the big square and the small square. And so what we do to find the area of this square? We would subtract these two. So that's the same thing that happens here algebraically. Minus 36 from both sides. They cancel, and b squared equals 64. So now we know the area of the other small square is 64. How do you find the side? You square root it. Square root of 64 is 8. Same thing right here. How do you cancel out a square? Or what is the, how would you get to b? Okay. You would square root it. Square and a square root cancel, giving you b, or the square root of b squared is b. Whatever you do to one side, you do to the other. The square root of 64 is 8. There's your answer. So again, here's the algebra. Here's the model. The one before, we were looking for the hypotenuse, the longest side. This one, we were looking for the leg, which is one of the shorter sides. And that's the basics of how Pythagorean theorem works.